Hello everybody, happy day to you. What we're going to do is we're going to do a warm-up problem that deals with flowcharts to go back off of what we did yesterday in class. And so what I want you to do to start is draw this triangle labeled accordingly, and like what we did yesterday, I want you to use those 5 shortcuts. We're going to choose one of them and write a flowchart to show that the triangles are congruent. So pause the video for a moment, work your way through, try and prove that these triangles are congruent to one another using a flowchart. Then after you are done, you can play the video and see what I came up with. All right, let's take a look at what you all did. First of all, I want to highlight that at first glance, it doesn't seem like we have enough information since we have 2 pairs of angles that are the same here. An angle at A and D and an angle at C and D as well. But one thing that I want to point out to you right now is that both triangles share this side. Although it's not marked in here, this is what we're going to refer to as a shared side. That's the same length in both triangles. And as such, what we can do is we can put a tick mark, or 2 tick marks, it doesn't really matter, down the middle, indicating that that length is going to be the same distance in both triangles. So now I have an angle, and a side, an angle, and a side in both triangles. And so if we remember our shortcuts from yesterday, in order to show that 2 triangles are congruent to one another, we had side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. In this case, what we're going to do is we're going to use angle, angle, side. As we have 2 pairs of angles and the side not included in between them, we're not going to use hypotenuse leg, even though we have a right triangle, because we do not right now have the hypotenuse in both. But here's what I ended up doing in my work so that you can see what I ended up getting from my flowchart. I listed out the 2 angles that were the same, which were A and C, and then D and D. And then the third side, which is BD. So BD was equal to BD. We call that a shared side. Therefore, by angle, angle, side triangle, ABD is congruent to CBD. And again, reminder, very important, the order in which you list the letters. A and C must be listed in the same order, B and B in the same order, and then D and D in the same order by angle, angle, side. So that was the warm-up. Then in order to start your notes for the lesson today, this is going to come from a new chapter. So this is going to be lesson 8.1.1/8.1.2. And today what we're talking about are polygons and their angles. So that would be the title for your notes section today, polygons and their angles. And I just want to talk a little bit about, first of all, what is a polygon? And so I'm going to write down the definition for a polygon, and then you can follow along with me. So what are polygons? Polygons, as I wrote down here, are 2-dimensional figures that are entirely closed and made up of straight lines connected end to end. These lines do not cross. So I've written some examples here of shapes that could be or could not be polygons. This first one is a triangle. That is a polygon, according to our definition. So yes, that's a polygon. The second one is no. This is not a polygon, as we have a curved line. So that's not a polygon. This third one that I've written down here is definitely a polygon. It fits the criteria listed above. So does the fourth one, that's star. But there is another star that I could draw that would look something like this, where my lines are crossing those straight lines. And this would be no in this instance because we have crossing lines. And that's not allowed when it comes to polygons. We don't like when that happens. So that's the basic working definition of what a polygon is. 2-dimensional figure, entirely closed, straight lines, the lines don't cross. Okay, you've actually been experienced, or exposed rather, to a specific kind of polygon that I want to make sure you get down, which is called a regular polygon. So this is the next definition to get down, this regular polygon. We actually talked about this earlier on in the course together. This is a polygon, so it's the shape that we talked about just above here is a polygon with all the same sides and all the same angles. So even though it's a small word, this word regular right here, that's an important word. That word regular implies that all of the angles are the same and all of the sides are the same as one another. And so you know some shapes that make that happen. Okay, what if I were to take a four-sided polygon that had all the same angles and all the same sides? Well, we refer to that as a square. So this is a regular polygon. This is technically a regular quadrilateral. That's the name that we give it. But more commonly, we refer to that as a square. And so that's a regular quadrilateral. And then we have other shapes like a five-sided shape we call a pentagon. And so this can be regular as well if we were to make all of the angles and all of the sides the same measure. We don't have a specific name for that, but we would call this thing here a regular pentagon. Pentagon meaning it's a five-sided polygon. So those are going to come into play here in a little while. And so we have polygons and then more specifically a regular polygon. A couple more vocab words that I just want to get across before we move forward. There's just a little bit left to write down. And it's the word convex versus non-convex polygons. And non-convex we also will call concave. And so this is something, another way or another characteristic that we can describe or that we can attribute to polygons. So convex is the first word that I want to, in essence, go over. And the word convex is a polygon where any 2 points can be connected and the line segment stays on the inside. So it is a polygon where connecting any 2 points stays inside the polygon. And so maybe an example would be better to see that. And so if I were to draw, for example, a rectangle or a four-sided polygon like this, if I were to connect any of the 2 points like this, or even if I went side to side, I would say inside the polygon or inside or in the interior of it. And so I would call this then convex. That's what we refer to a convex polygon. Connecting any of those 2 points stays inside. Now, the other portion of it, concave or non-convex, hopefully you can figure out what that means. Just base it off of the working definition. Concave or non-convex implies that connecting a line segment that goes outside the figure. So if you connect something that goes outside of the figure, then that would actually make it non-convex, or the opposite of what we were just talking about. And so the shape that I would use would be this star that I drew before. This is a polygon, this star. It fits all the criteria. But if I were to connect these two endpoints right here, that clearly goes outside of the figure. And so I would describe this shape as concave or non-convex. Or if I were to draw another example from up above, I could have something that looks like this. If I have any segment that connects the 2 points together that goes outside the figure, that's referred to as concave or non-convex. And so then the last little piece of information that we're going to do for today is to talk about the different names that we give to any polygon. So we know polygons can have different numbers of sides. And so what I'm going to ask that you do in order to finish our work is create a table, and I'll set it up that looks something like the following. So what do we got going on right now? I have a table that's going to list out the number of sides of our polygon. I would ask that you copy this down, and we're going to give us the name of that polygon. And so in order to do that, what we're going to do is we are going to talk about just the different names, and then this last column, the sum of the interior angles. So if we have a three-sided polygon, we have a specific name for that, and of course we call that a triangle. You're familiar with a three-sided polygon. When we add up all of the inside angles of a triangle, we know that makes 180 degrees. So that's what that looks like there. Then as we move on to four-sided polygon, we call that a quadrilateral. Now there's more specific kinds of quadrilaterals we're familiar with, but the basic is a quadrilateral with four sides, and we know that the inside angles of that add up to make 360. What I want you to notice here is that what I'm doing is I'm adding 180 degrees. A five-sided shape is called a pentagon. A five-sided polygon we refer to as a pentagon. And that has 540 degrees on the inside angles. If you were to add up all five angles in a pentagon, they add up to make 540 degrees. So what I'm going to do is I'm going to have you write those down. I'm going to pause the video and fill in the rest of them, and then we will touch base momentarily. Alrighty, so I filled in the rest of this. You can see the names of the different polygons. We have hexagon, pentagon, septagon or heptagon. That's the name that we give to a seven-sided polygon. Either one works. Octagon, nonagon, decagon, dodecagon, and then this thing called n-gon. This thing that's n-gon at the end, this all the way down here, just refers to any shape that's essentially beyond 12. We have some special names for all of these that have certain number of sides, but if you have like a 13-sided shape, we don't have a special name for it. We just call that a 13-gon. And so regardless of the number of sides that it has, if it has n sides, we can figure out the sum of the interior angles by using this formula here, n minus 2 times 180. And so if you plugged in n, the number of sides, subtracted 2 from it, and then multiplied by 180, that would tell you the sum of the interior angles. So that kind of concludes the lesson for today. What I would ask that you guys do is make sure you're diligent with taking these notes down, do your concept check, and then start working on your homework, and we will touch base tomorrow. Thank you.